Okay, so go ahead and write that down. Domain is all the possible inputs. Range is all the possible outputs, y values. Um, so quite often we're going to be asked, what is the domain and what is the range? So let's get into that. Here we go. So what are the domain and range of this relation? So just think about where's your x and where's your y. In ordered pairs, the first number in the ordered pair is your x value. So this is your domain. That's my domain. And the range is going to be those values. So we're going to list these in a set. So let's list this in a set. So this is going to be my set. And it's not an ordered set. It's just all the possible x values. So they don't have to go from least to greatest or anything like that. They just have to all be there. And if they appear more than once, you just list them once. So you'll see that right now. So let's see, 8. I have 8. Then I also have 2, 6, -1, -10. So that's my domain. Those are all the possible inputs in this relation. Let's move on to the range. Bless you. Okay, the range is going to be all of these values. And we're going to start with -5 and 1 and 2 and 6. And I'm going to stop there. Why am I stopping at 6? I already have the 1, right? We already have 1, so we just have to list all the possible ones. We don't repeat them really. Okay. Any questions? All right. I'd like you to try the next one. Look at each point. I'm just darkening in the points. Look at each point here. This relation is graphic. We got a graph. So let's do the same thing. Domain and range. And we only have a finite number of points. Finite means it's a countable amount. It doesn't go on forever. It's kind of the reverse of infinite. We could do this a couple of ways. One way is figure out the coordinates for each one. So I think that's what I'm going to do. -2, 1. I'm just going to go across. -1, -1. And then we have 0, 1. And let's see, then I have 3, -2. Oh, can someone get that door, please? All right. What's next? 4, 3. And finally, 5, -5. Okay. So now we have a bunch of ordered pairs. Pluck out the x values. And that's going to be your domain. What did I do there? I was thinking ordered pair. So -1, 0, 3, 4, 5. All right. Let's go on to the range. So now we want our y values. So 1, -1. Mhm. No, I could scramble them around if I want. On either set. I already have a 1, so I don't want another 1. -2, 3, and -5. So there's my domain, and there's a range for this graph. So that's a little review of domain and range. Eventually, we're going to figure out the domain and range when we graph stuff, actual things. Like if I were to graph a curve, and we're going to figure out what the domain and range is for that. Okay. Now, the thing is, say I have a graph, guys. Say I graph something like this. Okay? And say this graph goes as low as 2. So it's going to go all the way down to 0, 2. Right there, that point right there. If I want to figure out the domain and range, well, the domain is all the possible x values. This is x, and this is y. So take a look at this graph that I just made. By the way, this curve is called a parabola. And do you notice for the x values, I want to go to the positive direction, and I keep on looking up, and I should run into the curve. Will that ever end on the x sign? If I keep on going on the x-axis, will I ever stop finding the curve if I look up? Say I'm way over here, and I look up. Will I find the curve somewhere up there?
Yeah.
Forever. Same thing for the y, for the x side, infinitely on this way. Everywhere I look, it goes on forever. So the domain for this is -infinity to +infinity. It's all real numbers. Now the range is going to be different. Range is going to be everything I find if I'm on the y-axis. So say I'm at 1 right here at 1, and I look left and I look right. Will I ever find the curve? If I'm here and I look this way or I look this way, will I ever find the curve? No. Where will I start seeing the curve? Up at 2. At 2, I run into the curve, right? And if I continue to go up and I look left or right, will I find the curve? Greater than or equal to 2. But if we write it as an interval, it would, yeah. So basically, the range would be, yeah, anything 2 or greater. Because anything below that, we won't see the curve. So the range here is going to be bracket 2 to infinity. So domain is everything you find on the x-axis. Range is everything you find on the y-axis. And I don't see anything on the y-axis until I hit 2. Okay? Any questions? All right. Let's get into functions now. Let me know if you guys are ready to turn the page. All right. Function. So remember, if you recall from last semester, it has kind of a weird definition. It's any relation. So a relation is when you connect one value with another value, such that any relation such that every input has only one output. Any relation such that every input has only one output. Another way to say that using the language of x and y is every x has only one y. Every x has only one y. So what that means is if you connect every x with a y and it doesn't connect to any other y's, then it's a function. But the reverse isn't true. You could have this x going to 7, like you could have the number 1 connected with 7, and then later on you could have like the number 10 connected with that same 7. So x's cannot cheat, but y's can. X's cannot cheat, but y's can. Remember we talked about that last year? It's controversial, but that's the rule for a function. All right. So state the domain range and is the relation a function? All right. Domain and range, super easy. What are my domain values? Okay. So domain right there. Last year you would have had to copy them again, but we know what we're talking about. Then the range is going to be all of these guys. So the question is this yes, it's a function? No, it's not. The x values will tell you. So let's see, 3 is with 16, 0 is with 6. Yeah, here's the problem. You can't have 3 connected with 16 and also 3 connected with another value, in this case 19. No function. Not a function. Okay. Let's see what's going on here. So we said not a function. So here's our domain, here's our range. Domain is all of these values. Range is all of these values. So let's see if this is a function. Consider this your x values. This is your y values. Are we repeating anything on the x side going to more than one thing? So it's a function. Okay. Try the other two, 5 and 6. So this one is a function. Let's look at 5 and 6. Again, we got a domain, we got a range. So what do you think? Yay or nay for number 5? Not a function. The range values 20 and 3 better talk to each other because you have something in the domain mapping out to two different things. That's a no. Okay, number 6, we got another mapping here. We got a domain, we got a range. Why not? Yeah. Although, remember we said Y's can cheat. So yes, maybe we should feel bad for 9 and 13 on the domain side, but it's okay. It's a function. Okay. So even though this is happening, it's okay. As long as we don't have domain values branching out to more than one thing, it's a function. So this one is a function. Okay. Okay. Let's talk about the other side. Are you guys ready? Okay, so the last thing we're going to talk about is this vertical line test. Okay, so I want you to read the vertical line test and then tell me what it means. Discuss with your table partner what you. Let's come back to this. Okay, so what does the vertical line test tell us? Yes. Mm-hmm. It tells us when something is or is not a function. Okay. How though? How can we tell if something's a function or not? Guys, I need everyone's attention. So if I draw a line through the graph, not just any line, yeah. If I draw a vertical line through the graph, if I am able to draw a vertical line through the graph and that vertical line touches the graph more than one time, then it's not a function. Okay. So remember this from last year? Yeah. Vertical line test? Yep. So does it matter? So I have a question. Does it matter that I can draw a vertical line that only touches once, like the one that's only tangent at that one point? Yeah. So that point's good. But remember it says if it exists. And here there does exist lines that I can draw. So my question to you guys is this. Even though I can draw one that touches only once, is it a function? Why not? Okay. Bottom line, that's what it is. X's can't cheat, right? And here, this X value, whatever it is cheating. It has two Y values. That's what the vertical line tells us when X's are cheating and when they're not. So this is not a function. Okay. Let's try these two graphs. Okay. So this graph here, function or not a function? Only way you can really tell is where you suspect it might not be a function, draw some vertical lines. Maybe my third one is not so vertical, but you get the point. Is this a function or not? Is. Okay, so I want you to take the remaining 5 and try them out, see if they're functions or not. Okay? Test and see if those are or are not functions. Okay, about 30 more seconds. All right, let's take a look at this graph I'm going to call number 4. Function or not? This one here. Not. Touches a bunch of times. 3 to be exact. How about this one? Not. How about this one here? It is a function. How about this funny egg-shaped thing it's called an ellipse, by the way. That's the rotations around the sun are in this shape. Function or not? Nope. This cubic function, if you ever wondered what y equals x to the third graphs to, it's one of these. Function or not? Function. Okay. All right. So I'm hoping this is our review. It's back fresh in your memory. And this is what we're going to start with. Eventually, we're going to get into linear functions. Okay, so we have some IXLs, guys.